Hey guys, welcome back to my YouTube channel. So in this lecture, we are going to focus on special function gates. So there is only two special function gates, which is XNOR and XOR. So let's see first discuss about XOR. So XOR gate. So how the XOR gate output will be? First let me draw a diagrammatic representation of XOR. So this is how the XOR gate will be looking like. The output will be with this symbol, the XORs which will be represented with this symbol. So let me draw a truth table so that you guys will be able to understand the thing. So which is AB and here A XOR B. So 0 0 0 1 1 1. So if the input are different, then output will be 1. So this is the simple thing we can remember. If inputs are different, like 1 0 or 0 1, the output will be 1. If inputs are same, output will be 0. So this is for 2 input logic gate, it's fine. If we get 3 or more input, then how we can find? So the thing is that if input contains, so this is one of the very important logic, please make a note of it. If the input contains odd number of ones, odd number of ones or odd number of power value, then output will be 1. So even if you see here, the input is odd number, that means input means the number of ones is odd, so that output is 1. So if the output is even or input is even, then the output will be 0. Okay, so I hope it is understood, right? So this is commutative as well as associative. So this is both will come to picture here. So how we can represent this thing is that this can be represented as a bar b plus a b bar. So this is how a XOR can be expanded on output. So let's see how XNOR will look like. So XNOR. So XNOR is simply the complement of XOR. So just XNOR gate. So how we can represent this thing is that the same thing with the bubble. So this is a dot b. Instead of plus, we will be mentioning as dot. Okay. So let me. This will if we expand this one, then this will be a bar b bar plus ab. Okay. So this is commutative as well as associative. So let me draw a truth table here. So it will be opposite to that of previous one's truth table. So AB, A XNOR of B. So 0 0 0 1 1 0 1 1. There we see when the output is odd number, that will be 0, right? So this is exact opposite of that. So it is 0 0 and 1. Okay. So I hope this is able to, are you guys able to understand it, right? So here there is few things that we have to note it. So the XOR gate can be converted into XNOR if there is a complement in that. So that thing we know. So because that is an exact reverse thing. But there is another one thing that we have to note. So if A XOR A, both the input are same, we know that the output will be 0 because there is an odd number of ones in the input. So if there is A XOR A bar, then output will be 1 because this is considered as 0. A XOR 0 is given, then that is A. Because here also only one input is considered. So when A XOR 1, then output will be A bar. So if you substitute the thing, you will be able to get it. So if A XOR A, which is coming, then output will be A. The output will be based on A. Why the thing is that if all the entries are 1, 1, 1, 1, then input has odd number of ones, so output will be odd number of ones, 1 is. But if any one of the input is 0 and other is 1, then there is even number of input. So actually this cannot be possible because once this is 0, then everything will be 0. So then output will also be 0. Okay. So this is how we will be doing that. So if this 4 input is come, A XOR A XOR A XOR A, then output will be definitely 0 because there is an, if all the things are 1, then there is odd, not odd number of ones, there is even number of ones, so output will be 1. So the thing is that when n which is equal to odd, so when number of input to the input is odd, then we can clearly state some there is one difference is there. So if n is equal to even, means number of input. So let me complete another one table and let me fill this one. So here A XNOR of A, so which is equal to 1. This is quite the opposite of this one. So here A XNOR of A bar, so this is opposite of this one, which is 0. So here A XNOR of 0, which is equal to A bar. Here this is opposite. So A XNOR of 1, which is equal to opposite of this one. This is up to 2 input logic gate, this is fine. But if we go for a 3 input, so when we go for a 3 input, we have to consider different things. So when 3 input is here, then both the XOR and XNOR output will be same. So this is also same as like XOR. So when we go for 4 input, so when we go for a input, so the XOR and XNOR output will be complement to each other. So when it is 0, here it will be 1. So here we can state when input is odd, we can clearly state that all the operation in XOR which will be equal to XNOR. So this is one of the very important term. Plenty of indirect gate questions are asked here. So the both output will be same. The best example is this one, right? So this one. So if the input is even, then we can clearly state that the output will be exact opposite version of this one. So which is complement of the things. So here we have to add a complement. The example is this one. Okay. So this is one of the very important note, guys. So please make a note of it. So this is multiple times it was asked in gate examinations. Okay. So I hope you guys able to understand these things, right? So this is what the special function registers will how it is will work. So simple thing. So based upon the input, we have to answer it. So I hope you guys able to get all the functionalities in a special function register, basic function, as well as universal gate how it is works. So this is how the quiet things that we will be following here. So I will be having some providing you some problem sessions like how to solve the different problems in the upcoming lectures. So, or I will be even planning that to be separately. So once that is once all the background theories which are done, so I will be giving that also. So from next lecture we will be going into some more concept of sum of products and under the K-map things like SOP and those kind of things is there, right? So those things we can see like SOP and the POS, the product of sum of products. So those things will be detailedly discussing more on this. So for row, please understand this concept very clearly. If n, the number of input is odd, then the output for the 3 input gate XOR will be same as the XNOR. If the input is even, then the output will be different. What the output will be that you can use this one. If the number of input to input, if the input contain number of ones, the number of ones is odd, then output will be 1. So please make a note of it. So this will be very helpful for you guys to solve many questions. So I hope this is understood for you guys. If you think the video is informative, please like and share to your friends so that they can also get a note of it. So everybody can learn together. So please like, share and subscribe the channel. Stay tuned for next lectures. Thanks guys.